with Linux, you can have, there's a logical volume manager, which means that you can have a file system, part of which is on a rotating disk and part of which is on a solid state disk. You can do all sorts of things because you can even have a user-defined file system. So the user can write code, and when it goes to the operating system, the user's code is run to determine what happens. You can't do that on Windows, but with TeX, you actually don't need files except for input and output. Well, you can provide a proxy for output if you want to, or you can let the output go directly. For input, you don't need to get things from disk. You just need to say, here's the key, story.tex or whatever it is, and I'll give you access to the data you need. I won't give you the file name. I'll give you access to the data you need through a standard interface, which is the same as the file interface, if you like. If you've got a file descriptor, there are a number of things you can do with it. And I don't think TeX ever needs to do a select on a file descriptor, which is a real operating system thing. It's just basically reading the file descriptor. So that should allow stuff to work with perhaps a recompilation, optimistically with a recompilation. I say optimistic because I can't see all the problems. I can just see an optimistic route through. The outcome I'm looking for is there's enough use cases here and enough technical soundness to make it worth exploring. I'm not asking for people to bet the farm on it. I'm asking for feasibility studies, for special use cases to be solved. One of the use cases I'm really interested in is somebody's got a problem with their TeX file. And a recent example that came up on the accessibility list was, it was from a blind person, a blind TeX user, who discovered that the FI ligatures weren't showing in the screen reader. When I say showing, I mean hearing. You listen to it on the screen reader and the FI ligatures weren't there. And we haven't got to the bottom of why that happened, but if all the inputs could be gathered together and packed off, that would at least make the problem potentially reproducible. And if the inputs are given in terms of a secure hash, it means that we only have to send the inputs that aren't already on TeX Live. For the ones already on TeX Live, you just have to say, here's the secure hash. So if he's got a funny version of CMR10, that should show up because we'll secure hash the CMR10. And if it's not on TeX Live, we'll send that funny CMR10. But if it's the same hash as on TeX Live, we just need to send the hash. So the hash is a proxy as long as the person's got it. So the hash is a token for the object. So I see that as a very useful and interesting use case. If there are serious problems with this, I'd like them to be discovered early. It's always better in this sort of situation to get the bad news early. At the same time, it's worth doing proofs of concept. And a proof of concept is in a way of getting good news early, which is, well, this works at least in this situation, and you can try it in other situations to see that works. So one of the things that's really important to me is, in what circumstances does TeX do a seek on a file? When it reads a style file, I know it reads it line by line by line by line, so all it needs is a stream. But for example, when it opens up a format file, maybe it goes to the end to pick up a checksum or something. I don't know. I don't know those things. One can find these things out more easily on Linux.